Alright, draft physics video. Yay. Ken Wheeler. Yeah, I'll take notes, and I lost my last set of notes, so that was really dumb. Don't know where I put them, so I'll try to keep this one in some special sacred place where I don't lose it, so we can keep track and try to understand. Because Ken obviously, he knows, he's got the truth. And so we should really try to understand. Anyway, um, something like that. Alright, so I'll preface this. It's a video about light and inertia and perturbating and all that stuff. And so there's most people don't really think about this stuff, and this isn't really talked about. But you have these different kinds of things that look like forces, right? So you have gravity, you have magnetism, and then you have things like light and radiation and radio waves, the electromagnetic spectrum. Now everything on the electromagnetic spectrum doesn't need an ether or something to perturbate through, because the actual matter loses stuff to make the energy. So you can sort of understand it best with radioactivity, that the actual matter is being converted. The atoms are being changed into smaller atoms. I mean, fusion essentially kind of stuff is happening, where the atoms are degrading to create the radiation. And fission or fusion, on a very low scale. And that's why atoms have this decay rate. And the decay rate is them losing mass to create radiation. And then with radio waves or even photons, there's an actual destruction of some matter, in the sense that the electricity goes through the substance and degrades it in some sense to create the light. Or in this case of LEDs, that's the great thing about them, is that it's a conversion of the electrons, the movement of the electrons into light in a more efficient manner. And so, but it's still part of the heat equation. So instead of releasing heat, it's releasing light. Radiation in this form that isn't destructive to the material as much. But anyway, you can do an equation or an experiment, and you'll see that you don't get everything back. The light goes away, and that was mass that was in the what you put in. Now, gravity and magnetism are very different in the sense that neither one of those forces consume anything, any matter or electricity or energy. You don't put something in and get something that comes flying out, that somehow isn't part of this. I'm not saying this very well, but if you close the system, it's not thermodynamically sacrificing something. So there's something else that creates the energy. Something else. That's why they call them virtual photons for magnetism. And in the case of gravity, that's why they call it bent space. It's because it's not converting any kind of matter or energy that we know of, any flow of anything, into the thing that goes between the objects. There's no mass generated substance that moves between the earth and the sun, and there's no mass generated substance that moves between one magnet and another magnet. So that force has to come from some other thing. That's what I've pointed out is this field energy that is the real source of it. But anyway, so it's just a distinction that should be made clear, is that when Ken talks about this ether, it can't explain both things, because the two things are very different. The electromagnetic spectrum stuff is real energy that we see as matter in some form, and that's being converted. I mean, it's a real thing, and real movement has to go in and real movement goes out, where the other forces, there's no source so to speak, identified for the movement. Something like that. Could have done that more articulately, but so what? Yeah, there's a lot of things could have, should have, but didn't happen.
Okay. Part of, not the entirety thereof,
more volume
of the mystery of the parabolic telescope is that we're talking about incoherent light.
Alright, incoherent light. So, alright, so that's something we got to pay attention to. So coherent just means phase or out of phase, I think. And the other part of coherent, let's say I'll say, I'm not saying he's saying this, so we'll have to listen to get some better understanding about what he means by coherent. Alright, but it would have to do with the phase of all the little bits that he doesn't think exist. But anyway, all the bits come at the same exact period. So that would be at the same frequency, and they wouldn't diverge for too much. So they wouldn't spread out in their path as much. And we call that coherent light. So we'll use frequency and divergence as my understanding of the word. So that I'll put in my. Okay. So I don't know what he necessarily means by that concept.
Now, obviously, a pinprick of starlight falling on a single spot on a parabolic dish of a reflector telescope is not necessarily accurate, since we're talking about incoherent light. It is falling at every single point like a holographic paradigm, and they
so I don't know what he's trying to get to, but this goes back to the previous video, and there's nothing coherent about what he's saying here. The photons don't hit every spot. Different photons hit different spots. But yeah, the whole parabolic mirror is collecting photons from an object, and from all different kinds of angles, theoretically. Because see, say the object's very big, even though it looks like it's tiny, it's really very big in its real space. And the light on one side of the sun, let's say you're 1,000,000 miles from the sun, yeah, the light on one side and light on the other side was really, you know, thousands of miles apart when it started, not just a couple inches apart as we see it.
are being concentrated to a single point. So we're talking about incoherent light. None of you know about...
So I don't know. So that didn't help very much, because clearly you got to talk about these as individual perturbations of what we call light. And we know, he's a camera guy, he knows there's a lux factor, there's a certain number of bits of light that have to arrive somewhere for us to see something. So, you know, he's not saying anything too good here.
Much about coherent light in the case of a laser. What would be the difference between a 60-watt laser and these 60-watt light bulbs which are illuminating my ugly face?
Well, the first difference is it depends on how, you know, a 60-watt light bulb, LED light bulb, that you're actually using 60 watts. So we have to be fair in terms of your comparison. So if you're doing a 60-watt light bulb comparison to an incandescent light bulb that uses 60 watts, the amount of light you'll get out of that is a lot less than you get out of LEDs. So I'm just saying you have to make a fair comparison. So 60 watts worth of LED, see this one over here that's lighting me, it looks like it's a 60-watt incandescent light bulb, but it's only using 9 watts. So you'd have to make it 6 times brighter, which would be substantially bright. That would be like a 500-watt light bulb of the incandescent variety.
The 60-watt laser, depending on the frequency used, would burn right through me in about a half a second. All the way through me. A big, gaping hole. It would kill me instantly. Yet I can sit underneath these 60-watt fluorescent tubes all day long and only end up with dry eyes.
So he thinks there's something miraculous about that, and that just has to do with that inverse square thing, you know, where the laser beam is eliminating the inverse square law. So it's taking away this effect, just keep repeating it, this 4 times greater as you change the distance, half the distance. And so, yes, if you could concentrate all the power that's in the LED light bulb and focus it to a point, and then again increase its frequency, because frequency matters in terms of how it affects other matter. It doesn't matter in terms of the energy, it just matters that the material objects are more vulnerable to higher frequencies because they affect electrons more. They hurt atoms more. They disturb atoms more, the higher the frequency. There's not more energy, there's just more capacity to be disruptive.
Try eyes. Do you even understand, or do you think anybody...
Again, so, like this is some thing that we should all pause and say, can we possibly understand that if you focus something, it's like having a magnifying glass and I focus sunlight and it burns stuff. Is anybody impressed by that fact? So to compare laser beams to light bulbs and say it has to do with coherency, no, it has to do with concentration. It has to do with the fact that you took light that was covering this whole surface and you focused it to one tiny point. So obviously, instead of it diverging, as it naturally does, getting thinner, you made it thicker. It's no surprise.
He ever taught you what light actually was? Now, something prophetic that was said by Walter Russell, and Walter Russell never defined a field, and I digitized all his works, by the way, is that light doesn't move. He wrote an interesting little book called The Secret of Light. Now, if someone with a classical education, and this means a brainwashed moron, just like everybody out there, don't take offense at that, were to read that, they would scoff.
Don't take offense at that. Brainwashed moron. Don't take offense. Sorry, it doesn't work that way, Ken. I mean, you're supposed to be a smart guy and you don't think brainwashed moron is offensive. If I called you a brainwashed moron, you wouldn't be offended. Okay, sure. Should I write that down as one of your principles? Go ahead, call me a brainwashed moron.
So close the book and throw it in the garbage can. The notion that light does not move has not only been put forward by Walter Russell, but also...
So let's understand that the point I made earlier is that the one thing we know about light is that it's something in the matter that leaves the matter. And the loss is identifiable as a loss of mass. So the matter loses mass when it makes photons, just like it loses mass when it releases radiation. So it's to make an argument about it not moving, it clearly leaves the matter as mass. The mass gets smaller, it's losing mass. So to say it's not moving from one place to another, the mass isn't moving, what sense does that make?
By Eric Dollard.
And the thing that receives it gains mass. So that's the other catch. The thing receiving the energy actually does gain material substance. And it can reflect it, it can convert it into many things. And it can convert it into fatter atoms. Atoms that are storing more mass, more electrons.
That guy does nothing but live to experiment and read classical field theory. The notion that anything emits light is an absolute...
So that was Dullard, I guess.
Absolute ridiculous absurdity. If you think that a closed... Now, of course, they're filled with argon. A closed and vacuum-sealed glass tube like a conventional light bulb actually emits light, then you're brainwashed like everybody else.
So somehow you're brainwashed when there's tons of experimental evidence that demonstrates that's why they invented certain elements for filaments like tungsten and halogen lights, is because they found if you burn the metal at a high enough temperature, by evacuating all of and putting a gas in, that you could actually recover some of the matter that was getting destroyed in the process and have it, put back on the filament again, because the filament's degrading in the process of creating the light. So, but clearly we know that light is created, that mass is lost in the creation of the light.
Turn it on and emits light. No, then you're ignorantly assuming that if someone were to go into the middle of a large pond and start flapping their arms and the waves started lapping on the shore and hitting your little toenails there.
So again, that would be an analogy for an ether between the earth and the sun, or that might be an analogy for what a magnet's doing, even though I would say nothing's flapping in a magnet, and the earth certainly isn't flapping anything. But in this case, you're just wrong. I mean, the amount of energy that goes in, you calculate how much electricity goes in, and you calculate the total mass of the objects, and they can experimentally identify the loss in the system of the photons that leave. The photons do represent mass leaving.
That the person is emitting something. What has the person done that's in the middle of a placid pond and they start flapping their arms like they're drowning? What we actually have here is the medium that they're in, which would be the water. The waves are like pistons. Of course, pistons in your car don't move. They reciprocate up and down off the crankshaft, but the pistons don't actually move in the longitudinal fashion in which the car moves.
So, like, he's used this example before, which isn't a very good example because we understand that they convert motion this way into motion this way. And that's not a big mystery because you can kind of figure out that motion in a circle is really half of the circle's going this way and half's going this way. So there's no, I don't know I don't see the value of that analogy or metaphor.
No. Waves don't move either.
Okay, so waves don't move. They're just lumps in the ether. So waves don't move. So even though we know they do progress from one point to another, that they're a moving wave before they can possibly be a standing wave, because they do go from point A to point B, he's saying they don't move. Alright, so waves don't move from one point to another. So, like I said, we already know that's not true. So, I don't see how it makes no sense.
The only actually time that waves do move is when they actually hit the shore, and a few other instances where the actual shoreline starts to shallow and then the waves do actually move, but waves don't move either.
And like I said, they obviously progress, so there's movement in the sense of whatever's causing the wave moves.
Waves actually cause a bulk of waves to move, and on down the line.
Yeah, the wave causes the wave to move. Okay, so the wave moves, but the wave is moving the moving. There's just no, where are you going with this? Why is this an important subject? Again, the idea that it's pressure, okay, and that the pressure front moves, and that in doing that it doesn't move the substance here, doesn't get moved to someplace else. It's not moving the ether to another location, but clearly the pressure of the wave is moving. So you could have just said it better maybe.
The waves themselves do not move. If you think that
No, you should say the ether itself does not move. The water itself does not move forward. It just moves up and down. But it moves up and down because pressure is moving. The pressure is moving.
anything emits light, then you're as brainwashed as I was at an early age.
So even the word emitting light, clearly that's a generic enough word that you can't say that's a stupid word to use. Of course it's emitting light. Light emitting diode. I mean, come on.
And everybody else. Nothing emits light. We can go further down that rabbit hole and say that light doesn't.
So again, he's just arguing as if there's some nothing bumps into the ether. So the matter bumps the ether, and the ether transmits the bump to some other object, and then the bump is interpreted as a bump. But like I'm pointing out, that's not the case, because the stuff leaving this electromagnetic spectrum stuff, these tons are actually consuming something when they leave. Something leaves point A and goes to point B, and there's no denying that.
Not exist, because if we can only define light by what it does, then the concept of...
Well, that's not the only way you define something, is what it does. I could just stand here really, doing absolutely nothing, but that doesn't say, my guts are still doing stuff. Lots of stuff. My brain is still doing stuff. I mean, it's just silly to say I am what you see. No, I'm more than that.
Light, as expressed by human ignorance as a subject, cannot exist.
Light can't exist as a subject. I'll write that down just for fun. Can't exist as subject. I won't know what the fuck that means later, because I'll be like, well, what do you mean it can't exist as a subject? That's a silly thing to say.
In the analogy of Bob, if Bob were to stop walking and Bob vanished, then can we actually say that Bob ever existed? We only define something.
Yes, of course we could. We could see his footprints. We know he was there. So I mean, it's just silly. Again, another pointless analogy. What is, photons don't just disappear. They impact something and they create a chain reaction of new actions, and they might even just pop back out as another photon. So it's clear it's not some kind of thing that dies. Photons don't go anywhere and die.
By what it does and not by what it is, then therefore the principality or the subject, or the denotation of what we refer to in the subject in reference to light, certainly.
The definition of the orification of the definition of the orified definition is, I mean, what a bunch of useless jargon.
Cannot exist. When we speak of light, we speak of a frequency, we speak of a wavelength.
Okay, a frequency and a wavelength, which are, just the inverse of the same thing. So we speak of a frequency and a wavelength, a lambda, or whatever the fuck it is. Lambda.
Like we speak of an intensity.
An intensity. So frequency, wavelength aren't really intensity. Intensity is really number. So this is where me and him are going to diverge quite a bit. Frequency and wavelength does not equal, I'll put, intensity. But he thinks so. This is me again. Intensity is clearly number, and frequency and wavelength are important in terms of effectiveness. But effectiveness and intensity aren't the same thing.
In lumens or watts or lux, doesn't matter the measurement.
Yeah, well, those measurements are all again about volume. So those aren't about frequency, they're about volume.
Used, all of those are human contrivances of measure, just like time.
Well, they're not just a contrivance, there's actually something to be measured. There's an amount. There's a difference between a little bit of light and a lot of light. And so it's not a contrivancy of human beings that we recognize there can be, a little bit of fat and then a lot of fat. It's pretty easy to do. It's a pretty rational thing to do, is to recognize the difference between a lot and a little.
Time, of course, itself does not exist.
Well, whatever, it clearly happens. So to say something that's clearly happening doesn't exist would be, in my opinion, retarded. Obviously, everything doesn't happen instantaneously. So time must exist. So you can say, I don't believe in it. I believe in flat time. I believe in, whatever. It's not going to do you any good, because it's an insanely pointless premise to establish that time doesn't exist when it clearly does.
The shadow doesn't exist either.
Okay, it's clear there's things that aren't getting hit with light, so they're dark because there's no light hitting them. clearly it exists in the sense that we can recognize little bit of light hitting something and a lot of light hitting something, right? And the shadow is just something where you say, well, there's a source of light and it would hit that thing if something wasn't blocking it, creating a shadow. So something's preventing the light from getting to it.
Nor does the emptiness. We've reified these concepts as things that...
The emptiness. So nothing's ever empty because there's ether. Everything is ether perturbations. Okay, so we're back to that crap that, in my opinion, you can't use the same ether to explain very different phenomena. And magnetism and gravity are very different from electromagnetic radiation.
Actually exists. When I say the word unicorn, you have this idea of a stupid horse in your head with one horn, but we all know that unicorns don't exist. When I say the word like emptiness, or light, or time.
Emptiness or light or time. So again, these are very different things. I don't even know what an emptiness is, but I'm just saying, you know, space. There's no such thing as space.
In space.
There we go.
We have concepts, images in our brain of things that actually exist, but they certainly don't exist. Very certainly.
Okay, so space doesn't exist, time doesn't exist. You say and light doesn't exist. You know, I don't know if I need to write all that down because, you know, no. Space, time, empty, and light, or shadow. I guess it was shadow, don't exist. And clearly, you know, I don't know. So he wins with this argument. The non-existent things that we know exist.
And of course, no such thing as emptiness. This sort of nihilistic, neo-Zen.
So somehow it's nihilistic. So somehow you're a nihilist if you believe in the idea that there's stuff separated by non-stuff. So any notion of us not being you know, made out of some kind of universal jello, and everything's made out of the jello. Thick jello, thin jello, blah blah blah, but we all have to be jello. Whatever.
Stuff that actually came out of Japan, this nihilistic ritualism.
So I don't know what that has to do with it. So we're all nihilistic ritualists if we understand that photons have volume, and that means there's amounts of them. And if we understand that different kinds of energetic stuff has different characteristics, different properties, and can't be described or defined as being sourced by the same event or thing.
It postulates stuff like achieving emptiness. I translate ancient Pali and Romanized Sanskrit. There's no such thing as emptiness. Shunya, or shunyata, doesn't matter if you want to use Pali or Sanskrit. These are descriptors of something that's devoid of something else. Something is empty of something else. And you can say that Alaska is empty of palm trees, or you know, someone's head is empty of intelligence, but emptiness.
Right. But there's no such thing as empty space. So that's all he's really trying to say here. I mean, yes, we all know that, you know, there's stuff, and we don't see any empty between the stuff we see because we can't see all the little bits, and we can't see what's in between the little bits. But he's basically saying the little bits are just thick blobs of jello, and there's jello in between the thick blobs of jello.
Which is not a thing in itself.
I think that's what he's saying.
Of itself, by itself. Nor is it a principle or subject. If someone says, I went into meditation and I experienced emptiness. You experienced emptiness, huh? I love it when people say...
I love it when you reference totally obscure and can't possibly be relevant bullshit. You think people finding their guru home or something, or their whatever, their nirvana, are physicists? Yeah, sorry, no.
say I found emptiness or I experienced emptiness. I used to see those sort of pathetically ignorant comments all the time. It's like, well, if you're actually in emptiness, then you're actually, recall being in emptiness, then it wasn't empty. What do you mean by that? Well, subject precedes the object of negation, therefore we can say that you certainly did not achieve emptiness, nor did you even experience it. Well, sure I did. Well, who was the person that experienced it? Well, I was. Okay.
Well, yeah, and what you're experiencing is the void of palm trees. So you can identify all the things you're empty of. And clearly, in those contexts, what they're saying is they experienced the peace of non-harassing agenda, or, a lack of desire and a lack of will, that kind of emptiness. But clearly, you don't experience. Having an experience would be impossible if it was truly nothing. Then yes, you can't remember having a nothing.
So you were in emptiness, right? Yeah, I was, therefore it wasn't empty. What do you mean? Well, you were in there. How empty was it if you had experience of it and recollection of it? You also reified something that doesn't even exist. You tried to give...
Okay, so I mean, this is sort of straw man, right? Because who the fuck... I don't think there's a bunch of physicists who are saying those wacky people are important or significant to somehow to physics. So the fact that they're using a kind of an exaggerated word and saying they found emptiness, a lot of them say they found nirvana or something. And so that's a more defined concept of a kind of peace of mind. So, if they said peace of mind instead of emptiness, then is it okay? I mean, are you just gonna argue their semantics, their poor use of words? You're not really arguing a concept here.
Definition and parameters is something that actually has no existence whatsoever. Something is empty of something else. There's no such thing as emptiness, nor time, nor shadow. Shadow, of course, is a privation of light. Shadow is not a thing in itself.
Okay, right. So it's not a concept, and that's all we really identify everything as a concept. And some things, these concepts have properties, and some of them have material properties, and some of them have action properties, but I mean, they're all properties. And so we can recognize this concept of a shadow, what causes a lack of illumination, a lack of photons to hit a surface. We can understand that as a concept. To say it's nothing, it doesn't exist, it's excessive rhetoric. It's as excessive as one of these whatever. Using the word emptiness to describe their peace of mind. You're using the same kind of poor vocabulary to say it doesn't exist as a concept. Of course it does. As an event, as a thing that happens in the real universe. It really happens. Shadows really happen.
Itself by itself. It has no principality nor subjectivity. The concept of light is no different than time, space, shadow, and emptiness. Light itself does not exist. Well, sure it does. Everybody knows that light exists. I mean, light's what's hitting your ugly face right now from those light bulbs. No, it's a field perturbation.
Right, so again, we're back to this argument. If it was just a field perturbation, then where did the matter go? Where did the let's see how to say it precisely. Where did the energy go? This energy went in. Again, not like the magnet. No energy goes into a magnet to create magnetism. Even an electromagnet, all of the energy that's used up is radiated as heat from the resistance of the wire. There's no consumption of electricity to create magnetism. So it's very different. So you have this circumstance where real energy is in, or real matter is consumed. So energy goes in, creates photons, or matter is consumed and it creates photons, in the case of like the sun.
The field perturbation manifests, i.e. is reflected off my face and gives it tonality, which goes into the camera, which hits the sensor, because of the resistance. Everything in the universe is compatible.
Tonality. Alright, so here we go. Everything in the universe is resistance, capacitance, And I don't remember the other ones. We'll have to listen to them.
Capacitance, resistance, permeability, and permittivity.
Okay, permeability and permutivity. So the ability to be to pass through something would be permeability, and permutivity is resistance to that. And resistance and capacitance is storage, in my opinion. And resistance is, that's where the energy is converted.
If my cell
So I mean, the conversion of electricity in wires is creating photons, but they're infrared. We don't see them. When you turn on any electronic device and say the transformer has a bunch of wires in it, there's a bunch of light coming out of there. It's just not visible light.
was not here, there would be no manifestation of that field perturbation, which is, by its definition, resistance. Nothing emits light, period. Sure, light travels too. We know that light travels X number of hundreds of thousands of miles a second. Yeah, sure. No, that's the rate of induction. That's the rate of...
Okay, so the rate of induction, which, like, say if I accept that, it's how fast it moves through the medium because of how the medium transmits it. Even if I accepted that, it's still a speed. So we say the fastest medium, the thinnest medium light travels through, the speed of light is a certain speed in the thinnest medium. So you could at least say that, but it's clearly a speed with which it moves. I mean, to say it's not speed when it's doing exactly what a car is doing driving down the road. Your argument is the car is not only traveling through the atmosphere, but it's also traveling through the ether. So what's the difference?
Maximum rate of induction of a frequency with a longitudinal pulse perturbation and transverse electrical magnetic...
Okay, longitudinal pulse perturbation. Longitudinal pulse perturbation. I guess that's the upstroke.
components which give rise to the rate of induction due to the frequency, any frequency for that matter. If something has a spatial footprint or a transverse, i.e. the right-hand rule.
Right-hand rule. He likes this right-hand rule for some reason. Okay, so the right-hand rule, which just has to do with currents, are created opposite of voltage directions, but it doesn't. I would argue it's not really important.
If you know what the right-hand rule is, partakes of the right-hand rule of propagation and has a transverse component, i.e. a spatiality, then it must partake of a...
As a spatiality, transverse component, that's what trans-V-E-R-S component. Okay, now see, that's where he gets into real trouble, in my opinion, because you can say that about electrons flowing through a wire, or the energy between the electrons flowing through the wire. That has one of these transverse components in the sense that it's going to radiate energy transversely. But there's no evidence that photons are energy or transverse energy objects. Where's your experiment that demonstrates transverse energy component being radiated by a photon?
Rate of induction, that which we call the field perturbation, or the maximum rate of induction, or quote-unquote the speed of light, is not a speed at all. It's simply a rate of induction. Light does not exist. Nothing emits light.
Okay, so I mean, everything, when we say something has a rate, it happens at a rate. I mean, that's the same as, it equals sign speed. He's saying no, rate doesn't equal speed. And of course it does. In sensible, reasonable language. That's a perfectly acceptable, yes, those two words are similar.
Something sets up through the release of energy, transference of energy, and that's what's happening. You know, the light is plugged into the wall socket. The wall socket is connected to the power lines. Power lines connected to the generator. The generator is burning coal. It's burning nuclear. It's the change of one form of energy into another. And that energy I desire to manage.
Okay, now, but see, that's where you run into your problem, because that's not what magnets do, and that's not what the Earth is doing, and that's not what the Sun is doing. When it comes to gravity and magnetism, there's no evidence of your power station creating the phenomenon. The electricity moving through the wire, again, even in an electromagnet, there's no consumption of any electricity for the purpose of creating magnetism. It's completely consumed by the resistance, and it's creating infrared radiation, but it's not creating magnetism by deliberate conversion of the energy. There's no use of the energy to make the magnetism. The magnetism is just a byproduct of the electrons flowing through the conductor and rearranging the atomic structure to make it magnetic. And clearly there's no evidence that magnets get weaker or die, that they stop functioning because they use up their magnetism. There's no evidence that happens.
Manifest as a field perturbation, which we call light. But light is merely a concept. Light does not exist. Nothing emits light. If we can only define something by what it does, and if it stops doing that, like Bob walking, well, Bob's walking around, Bob stopped, and then he vanishes. Well, Bob doesn't exist. If we can only define something by its attributes.
Well, again, like I said, this is the key to the electromagnetic radiation, is that you can follow it everywhere. It has a past and it has a future, and it won't die. So you'll always be able to find where it went. It's not destroyed anywhere.
Attribute. In this case, we can say that light and illumination are one and the same thing, correct? And we could actually take it back.
Well, I wouldn't even bother with that idea of illumination, because that's just too human-centric. But the idea that photons go someplace and then they can interpret what they hit, in the sense that they will behave differently depending on the properties of what they hit, and we can understand those differences as different colors and shininess and reflectivity, and we can understand all kinds of concepts about how light behaves when it hits different atomic structure.
Ultimately, using Platonic retroduction, I actually state that illumination itself is purely conceptual as well. We're talking about transformation of energy. It's certainly so. Nothing emits light. Your camera does not have photon. And also, the notion of a photon is purely an arbitrary concept with zero.
Okay, so like I said, then you're destroying this idea of lux, the idea of volume, the idea of how much light gets into your camera, and those ideas are rock solid. So again, how does that make any sense to sit there and pretend that the idea of a small amount isn't a reality?
Zero basis in reality.
Yeah, no, it has a lot of basis in reality, in the sense that there's a certain amount of energy, and you can't make a photon any smaller than the certain amount. So there's a certain size, and you can't make it any smaller. So why can't you make it any smaller, would be the argument. Why can't I make a half a photon if photons don't exist?
There's absolutely no such thing as a photon. A photon is the misapprehension of the actual nature, the coaxial nature of light, which is a longitudinal pulse perturbation.
Okay, well, we did that longitudinal thing, and that's the coaxial cable thing. Oh, yeah, I don't really like that. Coax cable. I mean, I don't think that's going to help at all. I mean, it's, it has a going forward and a going back thing. And again, this is in the context where you don't want to describe it as something conserved. You don't want the idea that the photon goes back, because the idea is that energy was really consumed to make the photon, that it's a piece of energy. It's not the stuff that makes magnetism, and it's not the stuff that makes gravity in that sense. Well, it is, but it is for a different reason. It was stored and released. So it's just not what's in the field, it's what's being introduced into the field. Yeah, that still isn't right. Never mind on that one.
And with transverse electrical magnetic constituents, what's actually defining the frequency and the nature of light. Here's a quick trick question. What's the difference between X-rays and visible light and radio waves and UV? There is no difference. They're all one and the same thing with different frequencies. The higher the frequency, the smaller the spectrum.
Yeah, I think we all know that. So that's so again, it's kind of a straw man argument. Everybody knows there's a difference between the frequencies, and it's the same thing, just at a different frequency. And I think that's sort of what people understand. The notion, though, that there's somehow frequency equals more energy is wrong.
Spatial footprint, the higher the power. Energy equals nu v. Energy from a frequency of light equals Planck's constant times the frequency. Literally, the smaller.
Yeah, well, look, it's kind of obvious. If you only have if you only have a certain amount of time, and I have two guns, one that fires a bullet every second and one that fires a bullet every 2 seconds, and I only allow you 1 minute to shoot bullets, obviously the gun that shoots them every 2 seconds isn't going to be able to shoot as many bullets. But the bullets themselves are just as intense. There's just less of them.
The frequency and the smaller the spatial footprint, which of course goes along with what Dollard and Tesla and James Clerk Maxwell and Oliver Heaviside said, is that the smaller the space, the higher the capacitance, and of course this is the case. And then of course we're talking about counters.
No, all it means is the smaller the space, the correlate to that would be the less time it takes to consume it or travel it. So the more stuff you have in a smaller space, the more stuff you have per unit of time. That's all.
Space. Here, in which the case we have a smaller container is able to hold more stuff. Contrary to conventional existential logic and perceptions of pathetic humanity, a larger box holds more crap, or in the case of field theory, we actually have the inverse of that, where a smaller box is able to hold.
Well, obviously, I certainly would argue from my theory that it's obvious what the difference is. It's just there's more in the given amount of time. And if you shoot just 1 photon of ultraviolet or 1 photon of infrared, the amount of energy in the two are the same if you just limit it to an amount. But if you're shooting a volume that's not restricted and you're timing it, then obviously the ones being fired more often will create more energy because there's more of them.
More energy. But by that we only imply that it's able to tap off more energy from counter space, i.e. inertia, or the ether. What you call it doesn't make any difference. Mother Nature doesn't give a shit.
It makes a difference, yeah, it does though. So the ether is counter space. There's a whole bunch of other stuff too. I remember last time, but I'll have to remember. We have to do all these equivalencies. It doesn't matter what you call it. It does sort of matter what you call it. I mean, you really should come up with one term for it.
Is stupid human creatures refer to it as ether, inertia, or counter space. None of that matters. It is what it is.
Inertia. So I don't know who does that. I don't know who thinks ether is inertia. Inertia is a condition that matter has. It can either be moving or not moving. And whether it's moving or not moving is its inertia, its condition. So inertia is just another word for condition. What's its condition? Moving or not moving?
Naming it doesn't mean anything. That we give rationalization and conceptualization to something that doesn't exist, like light, which does not exist by definition. If we apply
it does not exist by definition, and by whose definition? Your definition. Clearly by my definition, the word is appropriately assigned to a phenomenon that can be, one of the ones we can actually sort of witness. indirectly, but decisively, quite decisively. I see a lot of stuff. Thank you, light.
Hardcore Platonic retroductive logic does not enlighten the pathetic average human creature. They, of course, reaffirm light, since they see
So anyway, we're pathetic human creatures. Pathetic.
it reflects off things, but they have no idea what the hell light is. You know, the quickest way to trip up a professor or a physicist...
And he explained it in this video somewhere, huh? Okay. It's a perturbation in the jello.
And I dare you to ask them this. Just say, you know, light slows down depending on the type of glass it is. Slows down, and slows down is also incorrect, but they'll accept that part. Slows down by about 30% when it enters glass.
You know, it's 40%, but whatever. You know, it's again, this is an argument, a straw man, because we know lots of physicists don't believe the light actually slows down. It just travels a longer path.
And then when it leaves that glass, it speeds back up again. Now, without breaking the law of conservation of energy, since there's nothing inside light that says we're leaving the glass, stick on your foot on the gas pedal and release more energy and speed back up. The only way you could actually answer that question is through the ether, through inertia.
Well, look, it fits another phenomenon. Obviously, gravity does a similar thing in that gravity moves at the speed of light, so to speak, changes in gravity. But obviously, when it moves through material bodies, it doesn't move the speed of light anymore. And obviously, those bodies can gain acceleration through the process, and actually, the gravity never leaves for a very long time. The speed of gravity through a human body might be, 15 hours.
The counter space. There's only one way on this earth to answer how light is able to, of course I've already refuted light and refuted that light has a speed. There's only one way to answer the phenomena which we call light and what it does after it leaves that glass, where it returns to its quote-unquote speed, which is actually a rate of induction. And that is through what I've explained in my book and explained in countless other videos, is that there's no such entity as light. Nothing emits light. It is a field perturbation.
Yeah, well, regardless, when it perturbates through this field and hits an object, and now perturbates through the object, all you're saying is the object somehow has a slower induction rate. And then when it's done going through the thicker ether, it still has the same momentum, the same force. The car is still, it's like a car going through a sticky road. I could put glue on the road. That doesn't mean that and if my foot's the same pressure on the accelerator, as soon as I get over the sticky part, I'm going to be going just as fast as I was before. I mean, I'll be accelerating because I lost speed going through the glue. But I mean, there's nothing about what I've changed. I haven't changed anything I'm doing. The environment sucks some energy out of me, and now I get my energy back. But it's nothing. The argument could be made the photon didn't change anything. It's the environment that slowed it down.
Is literally the nature of the field, that perturbation, and the rate of induction relative to capacitance, resistance, permeability, and permittivity of the medium through which it is being disturbed, because glass has a certain capacitance and resistance. We think of glass as an insulator, but is also a capacitor, as even the Massachusetts Institute of Technology has proven.
Well, everything that can collect a static charge could be technically described as a capacitor, but that technical description isn't necessarily very useful.
All you have to do is ask some idiot, some moron, some brain-dead, mental midget, knuckle-dragging, subhuman, monobrow goon that calls themselves a professor, explain how light, quote-unquote, speeds back up after it leaves.
Oh, again, it doesn't speed back up. It was retarded by the environment, and now it's free to be not retarded anymore. It's not being, you'd use the example of, like, a car could be going by and I could hit it with sticks. And okay, so I'm slowing down its progress because I'm hitting it with sticks, and as soon as I stop hitting it with sticks, it goes back to its normal speed. The car didn't do anything different. It's the sticks that were slowing it down. I mean, come on.
They are guaranteed to either laugh at you or not answer you or give you the most absurd, illogical BS answer that anybody with half a brain could ever think of getting. Like, what the hell did you just say? They can't answer it.
Well, so he just keeps saying they can't answer it. And what he should do is show a demonstration of them not answering it. So show a clip of one of these scientists giving this fake, phony, silly non-answer. So go ahead and you know be at least more honest in terms of showing us how professors don't have an answer to the question, and show that well the fact is they do have answers, you just don't like their answer. So just show their answer and say, look, this is why I don't like this answer. But I mean, this bullshit kind of argument pretending they don't have an answer, they do have answers. You just don't like them.
They can't answer it. And I have no problem with people that are ignorant, so I just don't know. There's nothing wrong with ignorance. The problem I have is with these assholes with degrees that pretend to know everything and teach people the crap that they think they understand, and it's just a big pack of BS. It's just all it is. It's okay.
Yeah, well, why don't you take on some of the BS? Why don't you actually debate somebody with a physics degree or a professor or somebody else? Why don't you do it? Or me? There's lots of people probably willing to debate you on the subject. Why don't you take them on? If you're so confident that you have the right answer, won't your right answer look super cool next to their wrong answer? So why don't you make this comparison? Why don't you show this is their silly answer, this is my great answer? Why don't you do that?
Not to know. But the problem is that when someone thinks they know the answer to something, they don't go looking for that answer. That is so...
Yeah, I don't see what answers you're looking for. So, I mean, you're just describing your own asshole. It's just really pointless. You have one asshole. Newsflash.
Oh, and
And I think yours is more gaping than theirs. I think they're full of shit, their asshole, but yours is full of more shit.
applies to everything in life, too. If you think you know the answer to something, you will not go looking for the answer to that thing because you think you already know it. And that just makes you a pig-headed dumbass, just as anybody else, especially these people.
Again, you seem like the pig-headed dumbass. You're the one saying, I've done it, I've got the answer. So again, you're the perfect illustration of the asshole you're describing. So that doesn't make any sense. Where's your humility here saying I could be wrong? Where are you talking about, well, I think maybe possibly it's this way? Where do you do any of that? No, you completely insult anybody who disagrees with you as a knuckle-dragging, fetus-eating moron.
Professors, these pathetic little I've got a degree, boy! Yeah, a degree, papers are for dogs, not for human beings. I got a degree on the wall, boy! Yeah, all that means is that...
Yeah, so, and this is coming from the guy who just keeps pointing out it. I translate Sanskrit and poop cricketing. And snotty's not. So you're always sitting there, look at my badges. Look, I have badges. Look at all my badges. You're obsessed with your badgetation, you silly person.
That they got a degree by agreeing with the assholes who taught them the same sort of bull crap that they're teaching you. Their degree doesn't mean anything. It does not.
Well, so I can say that your knowledge of ancient languages doesn't mean anything, and I sincerely believe it doesn't mean anything because I don't think the ancients had any brilliant insights into fucking reality, frankly. They were ignorant of like 99% of what we've learned in the last 500 or 700 years, and it's pretty impressive what we've learned. So this bullshit argument that we need to go back to the ancients to find out the truth is, I think, on its face kind of silly. I mean, it is. You don't go backward to go forward. No.
I mean anything. It means something to stupid people, but intelligent and wise people specifically, it doesn't mean a damn thing. Try to ask them that question about light leaving glass. Because
it's sort of, to say that it doesn't mean anything to learn all of these basic, knowledge points of experiments and, what could be deduced from the experiments and all that stuff. I'm not saying they should turn it into a dogma that they have turned it into. But knowledge of the experiments is kind of important if you're going to opine on the subject of what stuff does or what stuff is. And I don't see your knowledge of experiments being very extensive at all.
So their answer, they'll either not answer, or they'll turn around and not answer you, ignore you, scoff at you, or they'll give you an answer that breaks the law of conservation of energy. There's only one way to answer.
Yeah, no, that's so he just keeps saying it, but he doesn't prove it. So he keeps making this accusation, especially about dead people, and he doesn't prove any of the accusation he makes. And it's just that's really that's being a poor sport, buddy.
The phenomena of light, since light is not a thing and light does not have a speed, there's only one way in this entire universe to answer that question. And that is vis-a-vis inertia.
So he concedes that the speed of light reduces when it goes through substances. So obviously the concept of speed has some relevance. It's something we can notice. And yet he says there's no speed of light. Of course, there's obviously a difference in how fast light moves through different mediums. So to say there's no speed would be it's uselessly excessive.
Ether, counter space, doesn't matter what you call it, and field perturbations. Because everything are fields, and fields are not particles. Well, when the photons leave the glass, it pushes off the glass like a spring. I've actually heard some professors say this sort of...
Prove it. Prove you've heard any professor ever say that. I've watched a ton of professors, never heard a professor say anything close to that. That's just bullshit. And even if there is one on Earth, he has to be the nutty professor or something. That's a ludicrous explanation, and he says he's heard it. Where did you hear that? Like a spring, it bounces faster. After it goes through the glass, it springs out of the glass. Where did you hear that?
Crap. As people say, I asked my professor that thing he told me to ask him, and they said when the light leaves the glass, it like pushes off of it and it speeds back. If you don't understand why that is a BS answer from the...
No, if you don't understand how that's crazy hearsay, and that's really inadmissible in a trial. I mean, you can't do that shit. I heard somebody say they saw him murder him. You know, you can't play that kind of game and have credibility. I mean, that's what a shyster lawyer does. That's not somebody playing an honest game does, that kind of bullshit. I heard somebody who said something about smelling a stupid fart he made, and, you know, it's all smelly. You know, I mean, this is bullshit.
Pits of hell, then you don't have enough brain cells to even breathe and keep yourself alive. This, folks, is what translating ancient Greek and having a sharp mind will do for you.
Well, right. You're fat, and you're talking about how long people are going to live. I mean, come on. You got to work on that because you're asking for trouble. I mean, yeah, they have lots of things now. You take a half aspirin, you do this and that, and you can avoid some trouble. And they do the whole bypassy thing and all that crap, but you're just marching right into a brick wall, and then you're telling other people how stupid they are and how they can't figure out how to survive. Your plan doesn't, you know, frankly, you know, you haven't proven it works yet. You know. What are you, barely out of your 30s?
In which case someone will reply, is that why you're covered in tattoos? That doesn't matter. Lux e veritas. If you like these videos, you always click the link below. Tell me you jump off a cliff, whatever makes you happy.
Yeah, well, whatever. I mean, it doesn't make me happy that you talk this rambly shit and people consume it, and it's very discouraging. And they do it because, oh, he's Ken and he's gay and funny, and you know, he's happy and gay and funny and friendly, except for he hates everybody who doesn't agree with him. You know, I don't know what exactly they're sucking up, but it's pretty disgusting. You know, we could read some of this suck up. My God, I love these kinds of videos where you say absolutely nothing reasonable or rational about important subjects of origins and such. I've tried to show to a couple of people that they were just looking like they were in outer space. I don't know what that means. Yeah, the people said, what are you talking about? This guy's nuts. What is he saying? I wish this mouse didn't do this. Let's see. Something that can't be proven to exist, though. So we're talking about galactic jets. Yeah, well, let's not play with that. Love these fireside chat. Here's a paper I wrote that models light as a capacitor. Oh, wonderful. Oh, it's Fractal Woman. She really is a sycophant for Ken. And this one I wrote on the medium for the propagation of light. Well, I guess I'll have to go see these. I think they might find these enlightening. Or there'll probably just be a bunch of Ken quotes in there. But anyway, yeah, I'll have to check that out. Oh, let's go check one out for the hell of it. Let's see if it shows up in any kind of readable fashion on this. I don't know what this website is. Oh dear, the figures. Yeah, she has Ken's little spots in there. I can see that. Oh dear. It's in tiny text and all that crap. Okay, well, we'll have to do that some other time. Anyway. I think I agree with stupid. Let's see, you should get a whiteboard to explain all this in more detail. Well, there's nothing. How can he explain a coaxial cable of light? I mean, come on. Since the glass causes the effect of light slowing down by 33%, it's 40, but whatever. And if part of the challenge question to someone is, how does light speed up after leaving glass? Let's read more. I asked this: if my glass-like material was used to farm the energy from the field perturbation, what would dictate the number of glass-like material walls I could use before the field perturbation was consumed? You can't consume it, you can only convert it. You can only convert it. Sorry, that's all you can do. Let's see. Genesis. No, we don't need that. As Ken often says, light perturbation is a rate of induction. I believe that light slows down in glass because ether is rarefied in the glass medium. Where ether is rarefied, then the rate of induction, the rate of propagation goes down. When light comes out of the glass medium, the rate of induction goes back up. So it's Fractal Woman again. So she's using exactly his rhetoric. Propagation, rarefication. Doesn't make any sense. If this is true, then light is no longer propagating in the glass, but instead is being treated as a hot potato. Why would the reason for light propagating be different in glass than in air or the vacuum of space? All transparent media, all media that allow light to shine through, contain rarefied ether. Okay, I asked my professor said light bounces from atom to atom, and then that's why it slows down, but don't buy it, but you should debunk it in a video. Yes, exactly. He should actually show the explanation and then show how he thinks the explanation is fundamentally flawed. Light slows down. Yeah, that's Fractal Woman again. Oh, come on, mouse. Just such a... I gotta get a better mouse, I guess. You purchased hot diaries of... I don't know. I wish you would do a series on debunking Western science one by one. Higgs boson, dark energy, neutrinos, quantum entanglement. Yeah, well, those are all... that's not really science. So he's debunking. He's arguing against really old physics. I mean Newton physics. Let's see. A 60-watt light bulb with a reflector and lens will burn just as badly at the focus point as a laser. There you go. Bravo. It won't be just as, because it's a mixture of different frequencies of light. And obviously, ultraviolet light is more destructive to the material compounds that people are made out of. So anyway, enough. Okay, not my best effort, but whatever. It is what it is. Maybe next time. Yeah. So till next time. Yeah, even these comments aren't really in the right place. Yes, until next time. And such, so forth and whatnot. Mostly.